guys, it's Anna. I'm here to go over section 2.7. That is our inverse functions section. I promise there's a method to my madness, and there is a reason why we're doing this section so much later in the semester. But today we're just going to go over inverse functions, what they are, how you find them, and other important vocab and information you need to know about them. So to start off, we're going to do a little recall from something that we did in the very first unit for the very first test we took. We did compositions of functions. And right now we have two functions, f of x equals 4x minus 7, and g of x equals x plus 7 divided by 4. And we're going to compose both of those functions. We're first going to do f of g of x, which means we're going to take our function f of x, so that's f of x equals 4x minus 7, and we are going to replace the x with our g of x, because we're doing f of g of x. So we will end up getting 4 times x plus 7 divided by 4 minus 7. And hopefully we see here that when I multiply this right here, 4 times something over 4, the 4s, you can imagine that's 4 over 1, and those 4s cancel. So you're left with x plus 7 minus 7, which plus 7 minus 7 cancels to 0, so this just equals x. Okay, so we're going to do the same thing, but now we're going to do g of f of x. So we're going to take g of x, which is x plus 7 over 4, and we're going to replace the x with f of x. So to get g of f of x, we end up having 4x minus 7 plus 7 over 4. Now, these parentheses aren't really necessary, so here we just have 4x plus 7 minus 7, minus 7 plus 7. Minus 7 plus 7 cancels to 0, so I'm left with 4x over 4, which just equals x. Okay, so this is important to know because this plays in directly to the definition of an inverse function. So, two functions, f and g, are inverses if the f of g of x equals x and g of f of x equals x. The inverse function of f is denoted by f inverse, or f to the negative 1. So right here, because when we compose those two functions with one another both ways, f of g of x and g of f of x, and we got x, both of those are equal to x, we know that these two functions are inverses of each other. So we could also denote this as f of x equals 4x minus 7, and f inverse of x equals x plus 7 divided by 4. We can use that fact to determine if two functions are inverses of one another. So what I'm going to do for this problem, this example right here, is we're going to find f of g of x. Okay, so we take our f of x, 3x minus 5 is f of x. We're going to replace the x with g of x. So it's going to be 3 times x plus 3 over 5. And hopefully you notice that something funky is going to happen. This is like Halloween colors. Or not funky enough happens. Nothing cancels here. So if I multiply this out, this is going to be equal to 3x plus 9 over 5 minus 5. And that's as simplified as it can go. I mean, I could try and get rid of the fraction, but there's really nothing else I really want to do with this. So this does not equal x, so therefore these two functions are not inverses of each other. Okay? This problem, this example, number 2, says the following functions are inverses. So they're already telling us that these are inverses. And based on the property we saw earlier, if I have f inverse of f, these two composed, that has to equal x, right? That's from the previous definition we saw. So if I have h inverse of h of 8, well, look here. That's just going to equal 8. You could go through the long process of composing h inverse of h and then finding out what that would be, but you're just going to end up getting x. And if we're using 8 as our x, then that's just our results. So please, please, please save yourself the time and the energy and don't do that full computation unless necessary. This last one. So here's a big thing about inverse functions. Their x and y values are switched. So if I have g of x and I get these points here, then g inverse of x is just the reverse of these. So if this is my x and y, then my y would become my x and my x becomes my y. So then g inverse would be these points or these coordinates. So this would be 7, -4, and then I would have -7, 3, and then I would have 3, go backwards, 3, 9. And those are my coordinates for my inverse. So when they ask me to find g inverse of -4, I'm going to find, okay, well, when is my x value -4 for the inverse? What is my y value? So that is equal to -7. All right, so a big thing is, how do we actually find the inverse of a function? And it's actually these nice steps. It's very repetitive. If you do a lot of practice problems, this will hopefully come really easily to you. So the first step is you're going to replace the f of x with a y. Okay. Then you're going to interchange the x and the y, or switch them. You might want to think of this as swap the x and the y. Then you solve for y, and then you replace the y with the inverse notation. So let's do number 4. All right, so find the inverse of f of x equals 3x minus 5. So that's going to be, we're going to first replace f of x with y, so it's going to be y equals 3x minus 5. Second step, we're going to swap our x and our y. So it's now going to be x equals 3y minus 5. Then we're going to solve for y. So we're going to add 5 to both sides. So I get x plus 5 equals 3y. And then we're going to have to solve for y by dividing by 3 on both sides. So I end up getting y equals x plus 5 over 3. Okay, and that is our inverse, but we can write it with the correct notation. F inverse of x equals x plus 5 divided by 3. Okay, so on this next one, I cleared it out so I can have enough space. We're going to find the inverse f of x equals 2x plus 8. So the inverse, first step, is we're going to change it to y equals 2x plus 8. Second step is we're going to swap our x and our y. So this is going to be x equals 2y plus 8. We're then going to solve for y. So I'm going to subtract 8 from both sides, and I get x minus 8 equals 2y. I'm going to divide both sides by 2, and we end up getting y equals x minus 8 divided by 2. Last step, we're going to rewrite that as f inverse of x equals x minus 8 divided by 2. The next video is going to have a couple more examples of solving for inverses, and it's going to go into a concept called one-to-one. So please make sure you watch the next video.